We are going to find this limit here, and the first thing that you might do is consider what happens as x gets really big. Well, the numerator would go to infinity, and the denominator would go to infinity. Now this is what we call an indeterminate form, and up to this point in Calculus 1, we have just had to rely on our algebra skills to find limits when we have these indeterminate forms. However, we have this new rule now. We have this L'Hopital's rule. So we're going to use L'Hopital's rule here, which says that we can take the derivative of the numerator and the denominator separately. That would be e to the x in the numerator and a 3x squared in the denominator, and we can take this limit and these two things are equal to each other. Sometimes what people will do to say that they use L'Hopital's rule is they'll put a little LH in between these two steps. So cool, what happens now as x goes to infinity? Well, the numerator goes to infinity and the denominator goes to infinity. So we should do it again. We can use L'Hopital's rule more than once. And again, the rule says that we take the derivative of the numerator, which, hey, again, is e to the x, and the derivative of the denominator, which in this case is 6x. So another ditto here, we get another indeterminate form. And whenever we have an indeterminate form, we can use L'Hopital's rule. We'll do it one more time. And the derivative of the numerator is again e to the x. The derivative of the denominator is 6. Now, when we take our limit as x goes to infinity, this goes to infinity over 6, which is just infinity still. That is no longer an indeterminate form. It is just infinity. So that completes this problem, but as a side note, what are indeterminate form? Infinity over infinity is an indeterminate form. 0 over 0, if we take a limit and our base goes to 0 and our power goes to infinity, that is an indeterminate form. And if our base goes to infinity and our power goes to 0, that's an indeterminate form as well. Other indeterminate forms, if we have infinity minus infinity, you don't know what that is. 0 to the 0 can be considered indeterminate, as well as 1 to the infinity, and 0 times infinity. All indeterminate forms, but the only ones that L'Hopital's rule really applies to are these. So there are cases where we can take some of these other indeterminate forms and rewrite them into this indeterminate form, and then use L'Hopital's rule. And in case you don't have your book open or didn't Google it, that right there is what L'Hopital's rule looks like. The limit as x approaches some value of an f of x over a g of x is equal to the limit as x approaches that same value of f prime of x over g prime of x. That's just what we did over here. We took some derivatives of the numerator and denominator separately and said that those limits were equal to each other. Now this is only true when our limit is in the indeterminate form 0 over 0, or infinity over infinity. And if you want, you can include plus and minus infinity in there as well. Okay, let's go to the next problem.